In last point we have seen the expression for potential energy and then find out the formula is delta U is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R. Now the SI unit of potential energy. We already know that energy SI unit of energy is joule. So here potential, also the formula for potential energy is joule. So 1 joule means 1 joule is the energy stored in moving a charge of 1 coulomb through a potential difference of 1 volt. Okay, and another convenient SI unit of energy is electron volt, means EV. So 1 electron volt is equal to 1.6 into 10 raised to minus 19 joule, or 1 milli electron volt is equal to 1.6 into 10 raised to minus 22 joule. So we know that milli means 1 into 10 raised to minus 3. So minus 3 or 10 raised to minus 19, we get minus 19 plus minus 3. So we get here minus 22 joule. Similarly, for 1 kilo electron volt is equal to 1.6 into 10 raised to minus 16 joule. Why? Because of kilo means 10 raised to 3. So 10 raised to 3 is the plus, and so minus of 10 raised to 19. So we get here minus of 10 raised to 16 joule. Okay. So now our next point is concept of potential. So now in this concept we see what is the potential difference. Okay. So here Q2 and Q1 is the two charges. So Q1 charge come near to the Q2 point. So work is done. Then work is done. Then we get a potential energy. So the distance from this Q1 to Q2 charge is the R. So the potential energy of a two particle system at a distance r from each other. So energy U for R energy. Okay. So R is the distance of two charges. So energy of this distance of charges is 1 upon 4 pi epsilon naught Q1 Q2 upon R. So here write in this form is U means energy is distance R. Okay. So here Q1 upon 4 pi epsilon naught R into Q2. This formula also written in this form. Why written in this form? Because here Q2 charge exerted a force on Q1 charge. So here Q1 is the separate charge and Q2 is also a separate charge. So here potentials on Q1 charge and potential on Q2 charge is different. So this is the V1 means potential on charge Q1 at distance R is Q1 upon 4 pi epsilon naught R, and V2 is equal to Q2 upon 4 pi epsilon naught R. Okay. So we see this difference because of here potential on charge on the Q2 and potential on the charge of Q1. Here find out. So therefore UR is equal to Q2 upon 4 pi epsilon naught R Q1. This is also same formula. So where V1R and V2R the respective potentials of charges Q1 and Q2 at distance R from either. So from this formula we can say here electrostatic potential energy is equal to electric potential V into a charge Q. Correct? Because Q upon 4 pi epsilon naught R means potential. We already learned. So here this is the electric potential. Here Q2 charge, and here charge means Qn or Q1 or here Q2. Okay. So electrostatic potential V is equal to, so here rearrange this formula for electric potential. Electric potential V is equal to electrostatic potential energy per unit charge. Correct? Rearranging this equation, electric potential V is equal to U upon charge means electric potential energy per unit charge. Clear it? So V is equal to means electric potential is equal to U means electrostatic potential energy per unit charge. So electrostatic potential difference between any 2 points in an electric field can be written as, from this formula, V means electric potential. So electric potential between V1 and V2 means charge Q1 and Q2. So here V2 minus V1 is equal to U2 minus U1. U means electrical potential energy upon Q is equal to dW upon Q. What is the dW? dW means work done, because energy nothing but the work done. So here change in energy means difference in energy is the work done, dW. Okay. So all these formulas is necessary for the solving the numericals. So our next point is relation between electric field and electric potential. So electric field means E and electric potential means V. So what is the difference relation between E and V? Now let us see. So consider the electric field produced by a charge plus Q kept at point O. Let us calculate the work done to move a unit positive charge from point M to N, which is at a small distance dx from N. So again referring this figure, now here plus Q charge is exerted, E means electric field, and then a charge of at point M is moved to N point from the small distance dx, and so it's come to the point A, then OA is equal to is the distance of R. So the direction of the electric field at M is along OM, and the work done is equal to dW is equal to minus F dx. So we know that when work is done, then force is exerted. So electric force is exerted. So minus F dx. So minus sign indicates the force is opposite to work done. Okay, because the E is the direction of electric field. So here we say work done is equal to also minus E dx. So dW is equal to dV. This is the difference in potential between M and N. Already we know that the potential difference V2 minus V1. So dV is the potential difference is equal to minus E dx. Because this formula comes from this point. We already learned in previous point. We know that U is equal to energy is equal to nothing but dW. So V into Q charge. So dW is du. So dW upon Q naught is the charge is equal to V. So using this concept, here find out dV is equal to minus E dx. So E is equal to, rearrange this equation, E is equal to minus dV upon dx. So dV upon dx is nothing but potential gradient. So thus from this formula, electric field at the point in an electric field is the negative of the potential gradient at that point. You know that potential gradient means change in potential per unit length, but here length means here distance, so dV upon dx. Now next concept is zero potential. So what is the zero potential? Once the 0 point of the potential is set, then the every potential is measured with respect to that reference. Means here point Q, source charge place here, so positive Q charge, and next test charge, here source charge, and here test charge, place infinity of that charges, place that infinity distance. So here not exerted any force on that point because they are infinity, so we are not get here potential at that point at infinity. Okay, so here say that this is the zero potential. Okay, here potential is 0, means V is equal to 0.